Okay, for this next topic, we're looking at angles of elevation and angle of depression. So I wanted to first of all talk about what they are and how you actually measure them. So in the diagram, we've got a cliff, and for this cliff, there's the sea below it, and there's a boat sitting out in the ocean. Now, there's two types of measurements from here. One is an angle of depression, and the other is an angle of elevation. Now, the angle of depression is from the person on top of the cliff looking down at the boat from the horizontal line, and the angle of depression will be, say, 30 degrees. The other angle is for a person on the boat looking upwards, and the angle of elevation from the person on the boat looking up the top of the cliff will also be equal to 30 degrees. So for a horizontal, from the horizontal going downwards, I get the angle of depression, and from the horizontal line going upwards, I get an angle of elevation. So for all angles of elevation and angle of depression, the angle of elevation is also always equal to the angle of depression. So to do these problems, you need to remember that fact so that you can substitute your values into a triangle and to be able to calculate either the distance the boat is away from the cliff or the height of the cliff in problems. So let's take an example. Here's another one of a boat and a cliff. So the question is, how far is the ship from the base of the cliff? Now the information I'm given here is that the boat is D in here is my distance I've got to calculate. My boat distance here, which is going to be how far it is away from the cliff. Now, standing on the cliff looking down at the boat, a person sees that it's 55 degrees for an angle of depression. Now that 55 degrees is outside the triangle, and what we have to do is be able to try and get it inside the triangle to be able to do our calculations. So from above we know all the angles of elevation are equal to the angles of depression. So I can simply take the 55 degrees and write it inside the triangle as being the angle of elevation being the same. Now once I've done that, I've then got a triangle which I have an angle, an unknown side and a known side. So I'll redraw the triangle. I've got my 55 degrees in the corner. I've got my cliff, which is 120 metres. And I've got my D, which is my unknown side. Now the right angle corner, right angle is next to the cliff. So now I've created a right angle triangle with the information I need. So I've got to work out which one of the ratios I'm going to use to try and work out my D. Well, this is my hypotenuse side. This is my adjacent side, this is my opposite side. So the sides I've got are opposite and I've got adjacent. So my ratio I'm going to use will be my tan ratio. So tan of theta is equal to my opposite side divided by my adjacent. Alright, so let's substitute our values in. I know my theta is 55 degrees, so therefore tan of 55 degrees is equal to my opposite side, which is 120, divided by my D, which is my adjacent side. Alright, now the D, I need to get that to the left-hand side or to be the subject of my equation, so I have to move the D from the bottom over to the left-hand side. So my first step is to multiply both sides by D, so that I move the D off the bottom of my equation. So I cancel out those. I get therefore D is equal to tan of 55 degrees. Oops. Multiplied, we'll do that again. Tan of 55 degrees multiplied by D is equal to 120. Well, now the tan of 55 degrees is in the wrong place. The D is the correct place. I've got to move the tan of 55 degrees to the other side of my equation. So to remove it, I go divide by tan at 55 degrees, divide by tan at 55 degrees, and therefore D is equal to 120 degrees divided by tan 55 degrees. Alright, so on my calculator, I need to look up 120 divided by tan 55, which is 120 divided by 1.4281, and that ends up being 84.02, and I put M. So the distance that the boat is from the base of the cliff works out to be 84.02 metres. Alright, so let's have a look at example number 2. Example number 2, I've got a tower, and with this tower there's a person standing away from the tower, and the person is 1.5 metres in height and is looking up at the top of the tower. The tower has a height of h, because that's what we're trying to find, what the height of the tower will be, and the person is 450 metres away from the tower. So I'm going to split that into two things. I'm going to call this one h1 and h2. Now I know h2 is equal to 1.5 metres, because that's how tall the person is. So what I have to do is to try and find out what h1 is. The height from the eye level, or horizontal, up to the top of the tower. Okay, so let's just redraw that again. I'll redraw it as a triangle. So here's my tower, here's my person over here. This is 450 metres. My h1 is the height that I'm trying to calculate, and I've got 35.6 degrees. Alright, so which ratio do I need to use? Well, this is my opposite from the other side of my triangle. Okay, I've got my hypotenuse, no value there, but I do have my adjacent, ADJ. So I've got my opposite, and I've got my adjacent. So I'm going to use my tan ratio. Tan theta is equal to the opposite divided by the adjacent. Alright, well, let's substitute values in. Therefore, tan 35.6 degrees is the opposite, h1 divided by 450. Okay, so the h1 needs to be the subject, or the left-hand side, and the 450 is the thing I have to remove. So if I multiply both sides by 450, I'll cancel out the 450, and that'll just leave me with h1. So therefore h1 is equal to tan 35 degrees, 35.6 degrees, then I'll forget the 6 to make it accurate, multiplied by 450. Okay, so I look up tan 35.6 degrees in my calculator, and I round it to 4 decimal places. So I get 0.7159. I multiply it by 450, and I end up with an answer of 322.17 metres. Now that's not quite the answer, because the person is 1.5 metres high, which means that we have to add another 1.5 metres to my answer to get the true height from the ground up to the top of the tower. So my height is equal to h1 plus h2. h1, 322.17, and my h2 was 1.5 metres. So add those two together, I end up with 337.17 metres. So the height of my tower, total height of my tower from the ground up to the top is 337.17 metres. Alright, so could you have a go on page 55? There's some questions there. There's 19, 20, 21, 23 and 25. If you could draw the diagram down first, have a think about the sides that you know, have a think about the side you don't know, think about the angle of elevation and equaling the angle of depression, and then work out which one of the trig ratios you're going to put the values in to solve the problem. Thank you.